My pleasure. Good to be here. So, yes, just to clarify that I do indeed work in .NET now for Google. I lead the team building the Google Cloud client libraries for .NET. So if you want to talk to cloud services that Google hosts and you're doing it from .NET, then use our libraries. They're great. So that's probably all the plugs over. Let's dive straight into C#8. I've tried giving talks about C#8 a few times now, and every time it's slightly different in terms of approach, so I'm going to go in a slightly different order today. The biggest feature in C#8 is nullable reference types, so I'll probably spend about half the time on that, or possibly a little bit more, and we'll see where we go from there. So I'm going to dive straight into an example of why we need nullable reference types and what they do, and then I'll go back a little bit. So hopefully, well, you're likely to all have seen null reference exceptions. You know the pain of that, and you know that it's difficult to know whether something can or can't be null. Currently, we only have documentation to tell us. We'll go straight into an example. We have a very simple person class. So this is all valid C#7, even most of this code is valid C#6 and C#5. So this is just a person class with 3 properties and a constructor that simply copies the parameters to the properties. There is nothing special or clever going on. Don't look for anything special and clever. We then have a main method, which creates 2 person instances, one called John and one called Miguel, and then calls the print name length method with each of them. Again, nothing interesting here, except you'll note there's a green squiggly. I'll come back to that. Print name lengths is rather more long-winded than it really needs to be, particularly if you're used to interpolating string literals. But this will make things easier to explain later on. So we're copying the properties out of the person that we've been given, and then dereferencing each of those properties to find the length, and just printing out those lengths. Okay, nothing difficult so far. And can I just check you can all hear me and see the code okay? It's easier to do that having only shown easy stuff, so that I can tell when things get difficult whether it's the concepts or the technology that's being a problem. So can you all sort of raise a hand if everything's okay? Okay, I'm seeing a few hands raised. The stream down back to me doesn't seem to be terribly fast. I'm assuming I will be let known if something goes wrong. So let's just run this code, which will do what you'd expect it to do, I'm sure. Takes a little while sometimes with this. This is a preview build of Roslyn, which I suspect you can't get hold of at the moment. There are previews available. I've heard that they don't work with Visual Studio 15.8. I am running 15.8, but I happen to be using a preview that seems to work with it. But that's not a publicly available one. So you'll be able to use this in previews at some point, but you may not be able to right now. So if I run the basic demo, we get, it's wrapped in a target invocation exception, but we get a system.null reference exception, and it's at line 35 of print name lengths, and line 35 is this statement here. So first it managed to print out John, which is fine because I have a first, last, and middle name, but it failed with Miguel because Miguel doesn't have a middle name. All so far, so normal. All of this would behave exactly the same in C#7 and earlier. So let's look at this squiggle, which is sort of our entry point to C#8. And I strongly suspect that you wouldn't be able to read the warning, but it says, cannot convert null literal to non-nullable reference or unconstrained type parameter. That's a really, really long way of saying you're passing in null as an argument and you shouldn't. And this is where the feature of, well, not nullable reference types, but it's the feature around this that comes into play. In previous versions of C#, the code we've got so far all of these strings are effectively nullable, we know that you could pass in null as first name, last name, and middle name. There's no way to say that you can't pass in null. So you can think of those as being nullable reference types already, which makes the name of the feature being nullable reference types a little bit odd until you understand that when you're using C#8, and if you've got this feature turned on, and you'll be able to turn it on a module by module basis, maybe even file by file, that's still sort of up for decision. It changes the meaning of your code. It doesn't change how it behaves at all, but it changes the meaning so that this is now a non-nullable reference type, just by default. That's what string means, non-nullable string. This shouldn't have a null value. And that's why it's complaining when we try to pass in null for a parameter of type string. So we want to... We then need to decide what we actually want, which is, in this case, well, we want first name and last name to be non-nullable, but we'll make middle name kind of optional and allow it to be null. I should hasten to add, by the way, that this is not a good way of modeling names in general. It's very easy for us to understand, but not everyone does have a first name, not everyone does have a last name, etc. This is just for simplicity. So, if we want to tell the difference between first name and last name that can't be null and middle name that can be null, well, we do what you probably expect in the same way as if these were integers, we'd have int, and int question mark, meaning nullable int. We just put a question mark on. The difference between this and int is that this is actually, from the CLR perspective, this is the same type. We're just giving more information to the compiler. So the difference between nullable and non-nullable value types exists at execution time. The CLR knows all about it. The difference between nullable and non-nullable reference types is purely a source artifact. I mean, there's metadata that gets emitted within the IL so that the compiler for one assembly can know what's going on in another assembly, but it doesn't change the IL instructions that are generated. Okay, so now we've said that the middle name parameter can be null, and now our green squigglies have gone away. Yay! Unfortunately, they've just moved. They've moved to under here, and we now can't assign the middle name parameter, which is nullable, to the middle name property, which is non-nullable. Okay, that makes sense. So let's just make the property nullable. Great, the squigglies go away. And instead we've got two new squigglies. Now I'm just going to take a beat for a moment to say this process of moving the squigglies is entirely to be expected in C#8 when you first adopt it. You're playing whack-a-mole with warnings, basically, because you're gradually informing your code base about where you expect there to be null, where null is okay. And different bits, there's sort of a chain of reasoning that the compiler goes through, and if you've said that something can now be nullable, then something that was expecting it to be non-nullable has to change as well. Or you have to write code to handle the first part being null, even though the second part isn't. So, we've now got two squigglies, and I'm going to just talk about those briefly because they're slightly different. This first one is entirely understandable. We have a local variable of type non-nullable string, and we're trying to initialize it from a nullable string. Our middle name property is now nullable, so that's dangerous. I would point out we haven't changed what our code does at all, and I'll keep making this point. So if I ran the code now, it would still throw a null reference exception at the same point. It wouldn't throw a null reference exception here. It wouldn't. We wouldn't be even before we wouldn't be automatically validating that middle name is non-null here. The behavior is exactly the same, but the meaning of the code is changing, and that's what lets the compiler give you warnings. So this is only a warning, emits the same code, assigns a value of null to middle, which it sort of shouldn't do because middle is meant to be non-nullable. So that's why we've got this warning here. But this warning exists as well. It's dereferencing middle, and that's apparently not good as far as the compiler is concerned. We're fine with first and last, but not with middle. Now, in every other feature, that's a really weird thing to happen, because, and let me just move this so that we're going first, last, middle, everywhere. Everywhere else, what you can do with a variable just depends on the type of the variable. Here, we seem to have some extra information. It knows that first and last are okay, but it's concerned about middle, even for dereferencing. And this is where the C# compiler is taking extra information and propagating it to different bits of the code. So you will have seen this. If we were to do string middle, just declare it and not assign anything, then that becomes an error saying it's unassigned. So the C# compiler does already keep track of some things at different points of your code, keeps track of definite assignment. Well, nullability is a little bit like that. We're saying, or rather the C# compiler is saying, okay, you've got a variable of type middle, but I'm keeping track of where it can and can't actually be null, and I think it might be null here. And of course it's right, which is why we're getting the exception. So, the first thing we can do is fix this warning by saying, well, we expect that it might be null, so we'll explicitly tell the compiler that for the local variable. And obviously that doesn't get rid of this warning, because now we've told the compiler it really, really can be null as the actual type of the variable. So what can we do here? The simplest thing we can do is use the null conditional operator. So this was introduced in, I think, C#6. And it just allows you to safely dereference something, and if the sort of target reference is null, then it doesn't do the dereferencing. Instead, it gives a result of null. So now this argument, this expression, is of type nullable int instead of int. So we expect that when we run this, it will print first, last, and middle for me, and first, last, and middle for Miguel, but it'll print 6, and then, 8, and then just blank, because that's how a nullable int with a value of null gets printed. Let's just check that I am actually right on that front. Run basic demo, and yeah, we've got middle equals blank. Okay, well, that's quite nice. You know, the compiler has already saved us from a null reference exception, but it's kind of ugly that we've got that middle equals blank. How about we try to just not print middle equals at all if middle is null? Well, we can use the normal way. So you're probably familiar with using that. I would say that the idiomatic way, as of C#7 that has patterns, the idiomatic way of checking for a null reference is to use the is operator with a pattern that's the constant pattern of null. That way you don't need to worry about whether there will be overload resolution. So in fact, this doesn't call, rather this does something slightly different. This calls the string comparison rather than just checking for a null reference. So this is actually slightly more efficient, as well as really what we're interested in. And if middle is null, we're just going to print first and last. Not sure why the formatting's gone completely haywire for that. Let's just I'm very confused as to why the formatting didn't work nicely for that, but I think that's all valid. And now, really interestingly, we can make this just middle dot length. Okay, I'll just prove that it works, and then we'll come back to see why that's interesting. So, yep, we're now printing first, last, and middle for me, but just first and last for Miguel. Yay, this is what we wanted. And moreover, when we're printing middle dot length, we're convinced it's safe. Reasonably safe. That reasonably is part of the interesting aspect of this feature. So before, when we had string middle equals person.middle name and then used it with middle dot length, that was taking a variable of a non-nullable string type and dereferencing it, and the compiler still said, whoa, that's still unsafe. Now we've got the opposite situation where we've got a variable of type string question mark, but we're dereferencing it, and the compiler isn't warning us. And that's quite strange. But again, it's using its knowledge of, might this thing actually be null by the time we use it? And the answer is no, because we're already in the else branch of something that says, well, if it is null, we'll do one thing, otherwise we'll do something else. So the compiler is doing its best to save you from unnecessary warnings, but it's not. But it has to do that via some interesting mechanisms. I would point out it's entirely possible to have warning-free code that still goes bang. There are a few ways that this can happen. One is that the compiler isn't just keeping track of variables. Here we have a local variable. It would be the same if we had a field, which is slightly worrying in itself. And also, interestingly, it keeps track of properties. So here we have what looks somewhat reasonable, a name property that might be null, and we've got a method that's, let's say, maybe print name length. And we say, if the property isn't null, then print its length. Great, unless you have, for one thing, another thread that changes the name property from non-null to null after we've done the check, but before we do the dereferencing. Or more, what if we have a pathologically nasty... Oh, your video has cut out. No, you're back. Okay, can everyone still hear me? Yes, good. Right. Suppose we have a pathologically nasty property that is something like this. So most of the time it returns null, but sometimes it returns not null. And it's entirely feasible for it to return not null here and then return null here. And the compiler isn't trying to guard against that. And the reason it's fine that it isn't trying to guard against that is this is horrible code that you shouldn't have. If you have a property that changes itself sort of randomly between nullity and non-nullity, that's not great. I would say that UTC now shouldn't be a property. It should be a method, ideally on a clock interface or something. But it's unfortunate that it's a property that changes sort of its own volition. But even without that, even if we go back to the getter and setter, we still have the problem of, well, it could be changed from other threads. So let me just see. Oh, yeah, that's better. So the compiler is trying to help you as best it can. It is not guaranteeing anything. And furthermore, as I keep saying, the guarantees or the aims aren't validated at execution time. So they're only validated where they currently are. When you try to dereference something, the runtime will check. But at other times, the compiler is not inserting more checks for you. I said there were two ways that the compiler would stop warning you even when things were wrong. And the other is another feature, in fact. So suppose we pass in null for our first name parameter, then that gives a warning. But we can tell the compiler, I think, or I want to do it anyway. You'd usually use this if you ever use it in production code, it's more for, I know that this is non-null, even if you think it's null. So we could do string x equals null, pass that in, and maybe we've actually got something that the compiler can't know that code here that modifies x. The compiler doesn't know that it's non-null, but we do, so we're saying, please just trust me. And you can use the exclamation mark or bang or damn it operator to say, oh, just let me pass it. Don't give me a warning. You can do that with the null literal itself, saying, I know better than you that null isn't null. And there's one place where I found that is very, very useful. No warnings or anything. This will go bang when we try to print name lengths in exactly the normal way. But suppose you have validation, which you should all have. And there are simpler ways of writing it than this, but just this is, or other more concise ways. but this is simple to demonstrate. Suppose you have this code. You really want to test that. And how are you going to test that? You want to pass in null. So it's good to be able to pass null in and get the exception out. And in order to do that without your tests having warnings, I found that you use this bang operator. Now, a related potential feature that doesn't exist in this preview, may never exist, it's only being discussed, is that doing this all over the place is really annoying. You still want that, and you shouldn't remove this code at all from any of your production code, because this feature is sort of an advisory. It's a helper. You probably don't have null problems. It's not a guarantee at all. So you want to put those guarantees in just as you do now. But isn't it annoying that it takes 4 annoying lines, and you've got to make sure that you get the right name of operator with the parameter? What has been discussed is allowing that. So putting a bang after the parameter name, or maybe, so Mads has good reasons for having it after the parameter name. I wouldn't be surprised if it actually ended up being after the parameter type. And the idea is that if you have that, the compiler will inject the exact argument null exception check that you would want. So if we get this feature, then yes, by all means, go ahead and remove all the code that checks for it all over the place. Otherwise, keep those validations in place. Okay, I'm trying to think of other things. Yes, other things to tell you about the null feature. The most important thing to understand about null reference types is around what it guarantees for you, what it doesn't, and why it's still a good feature. So we're used to type safety being pretty much absolute within C#. So a cast is a little bit like that bang operator that we showed before, except it is checked at execution time by the runtime. The nullable reference types feature is not like that. It is a helper, and it helps in 2 ways. Firstly, it does help you avoid null reference exceptions. More importantly, I would say, it helps you by allowing you to express your intent, which before we've never been able to do in plain old C# without sort of JetBrains annotations and things. We've never been able to say that middle name is different to last name and first name. Now we can, and that's a thoroughly, thoroughly good thing. So you may well find when you're going and playing whack-a-mole that you've got 2 bits of code, one of which really wants, even after you've thought about it a lot, one of which really wants a certain property to be nullable, and the other of which really wants it to be non-nullable. When you find a situation like that, then the feature has identified a bug, and that's a good thing. At other times, it's adding just more clarity for all the callers of your code, etc. So that the feature works in multiple ways, but do not expect it to provide the same kind of type safety as exists elsewhere in the language. I'll close by showing one thing that can't be expressed at the moment, but definitely will be able to express, and then a couple of language design questions that still aren't resolved. So, string dot is null or empty. I'm sure you're all aware of this static method that takes a string reference and returns true if that reference was null or a reference to an empty string, and false if it's not null and not empty. Given that description, it would be nice if we didn't get a warning here. So we can do, just as a reminder, if text is null and the warning goes away, that's fine. If we do, or rather, it's fine because at this point the compiler knows text is not null. Okay. If we go back to string dot is null or empty, now the compiler doesn't know, which is why it's giving a warning. We know because is null or empty returns true if it's null. And so we could just get rid of the warning by saying we know better than the compiler and use the bang operator. But wouldn't it be better if the compiler knew that string dot is null or empty, if that returns false, which is the only way we get into this else block, that means text is not null. Currently, there is no way of expressing that, but there may be, it's expected that there will be in the future. I believe the current preview, which this is not, actually has hard coding in for string.is null or empty to give exactly that experience. That hard coding should go away because we really want a general mechanism that library authors can use. So I write the NodeTime library, and I really want to be able to express that in some places, well, this may return null if you pass it null, or things like string.is null or empty. Let me give an example of that sort of null propagation. Here is a reasonable method, and if you pass in null, it will return null. If you pass in not null, it will return not null. So when we pass in something that the compiler is confident is not null, then the compiler should be confident that the output will not be null as well. Now, of course, assuming that there is an attribute that lets me express this, I could lie. Just like string.is null or empty could be broken. The compiler's not going to check that in the same way that it would for code contracts as a project, but the compiler should be able to understand what we're asserting about the method. So this is a contract towards callers that expresses information we can't currently express. So that will, I really hope that will come, and I wouldn't be 100% surprised if it comes to some extent in C# 8.0 and then gets expanded in 8.1. It's possible that we'll have a few sort of relatively hard-coded attributes to start with. Propagates, null. Now, we want to use name of input, but we can't, so we might have to use input, something like that, or not null on false input for the string.is null or empty case. You could have not null on true. So these would be relatively hard-coded ones. There could be eventually nullity of input goes to input. So the output. So if we take this as meaning the output of null input is null input. Is null output. Who knows? So there may be a sort of mini language involved here. That will take a fair amount of time to design, which is one reason that we don't have public betas yet and things. But expect all of that to come. Right, one final bit to make you go, what? Generics are painful for this feature, and I'll show you two ways in which they're painful. So, not that one. Awkward interface. Right, so hopefully you're all familiar with inequality comparer of T, which has one method of equals that takes two T's and says whether or not they're equal, and takes one T and gives the hash code of it. So, their string comparer has this, so you can say, please give ordinal comparisons, or case-insensitive comparisons, or culturally sensitive comparisons, etc. The difficulty is, this interface, written long before nullable reference types, has competing requirements. The equals method is meant to accept null, and if you pass in two null references, then, assuming that we're not talking about value types, or non-nullable value types, if you pass in null, it should return true, or false if exactly one of them is null, otherwise do the actual comparison. Fine. So that should accept null. Get hashcode is documented to throw argument null exception if you pass in null. So equals accepts null, get hashcode doesn't. So we can implement inequality comparer of string question mark, at which point the equals method has an appropriate signature, but then our get hashcode method looks like it's fine to accept null, no problems here, I'll return something sensible, and it actually throws argument null exception, which isn't much more helpful than throwing null reference exception. We could go the other way and say, okay, I want it to accept a string, at which point get hashcode is fine, because we've said, no, you can't pass in null, so you should expect an argument null exception. But we've also said that equals should accept strings, and yet it's dealing with nulls, and we've said that it shouldn't. So this is deeply weird. We sort of want to be able to have inequality comparer where equals accepts a t question mark and get hashcode accepts a t. Although that then leads to the question of, well, what does an inequality comparer of string question mark mean? Because you've then got, you would effectively have string question mark in some parts. As a simpler example of that sort of oddity, consider this really simple generic type. I've got a couple of constructors just to silence the compiler, but you could think of it as, you know, just these lines of code. Generic type of t that has a t property called value. Well, what does that mean for generic type of string question mark? That's fine, because we get a string question mark, and so value can be null. If we use a non-nullable version, then the compiler's perfectly happy with that. But what do we think the value of non-nullable string will be? It'll be null. Weird stuff has happened here. So you might think, well, maybe we should make this t question mark. And at that point, well, the non-nullable string part is okay, because we should change the local variable type. What on earth does this mean when we've got a generic type of string question mark? Is it string question mark question mark? It's very, very plausible that it'll be null, particularly nullable string. I don't have answers to that at the moment, and it's not clear to me from a language perspective what any of this should mean. So that's a different kind. How do I express what a method returns and how that relates to the input? That's a tractable problem that requires some work on the language design team and then the compiler team. This aspect is significantly harder, I would say. So we'll find out what happens in the future. I'll leave it there for nullable reference types, because we have plenty of other features to go through. But let's just pause while I've got this solution up, because I've got different solutions as different features are in different branches of Roslyn. Are there any questions at this point? I'm not seeing any hands going up, so I will assume that that means no. I don't know whether that means... Sorry?
That t string is null thing that guarantees that it's not null for the future, say string.length.
Yep.
If you use the string equals null, would it have the same effect?
Right, so I think you're asking where we've got this, can we do double equals instead? Is that?
Yes, exactly.
Yep. Right, okay, yes, the compiler recognises that, partly because we're expecting, the C# team is expecting people to use all of this on existing code. And I don't know about you, but very little of my code uses this at the moment, because most of it was written before C#7. I've got an awful lot of code like that. And so, yes, the C# compiler assumes, even if you're calling a user-defined operator, that if you compare something with the null literal like this, then it will do the right thing. Now, as it happens, I have an example where that's not the case. So here's an operator that says, well, whatever you pass in, I'm going to say they're not equal. And so I can try to do this, and the compiler is now entirely happy about it. But it shouldn't be, because the compiler is relying on us having a sensible implementation for equals. So again, the compiler, for the sake of productivity, the compiler isn't being as conservative as it might be. It could say, I don't trust anything. other than the is operator, and that would just lead to a load of spurious warnings. So this feature, probably more than any other feature I've ever seen in C#, is really a balancing act that's aimed at fixing problems that already exist, helping you avoid other problems, allowing you to declare code, declare your intent within code, but not performing as rigorous checking as some other features would require, because trying to do so would either be impossible or add a bunch of performance issues. You know, if the compiler started adding equals null checks everywhere that there was any assignment from non-nullable type, or even given that we could be called by code that doesn't have these warnings, it should have that equals null check on every parameter that's ever non-nullable, and that would be a huge performance issue because broken branch prediction can really cost a lot of cycles. So the team is very much working within, hey, we've got a language that's 15 years old or so, more than 15 years old. We need to work with existing large code bases. We can't just break everything, but we still want to give value. And that's what they've been really focusing on. Okay, any other questions, or shall I move on? Hearing none. Oh. Okay. The sound from your side isn't great, but I think someone said, I think you're good, which is fine. Okay, so I will start the next solution. So this solution has 3 features in, well, 4 features. It has switch expressions, extended patterns, indexes, and ranges. That may take the rest of our time, and just while the solution is loading up, I'll explain there's one other set of features that I won't probably get round to demonstrating today, which are around more async support. Let me just bump up the font here. Because they're all different hives, they get different different font sizes and settings for everything. I think I was at 24. Basically, there will be more language support for async in the form of async for each, async using statements that dispose of things asynchronously, obviously with a new interface, async disposable, async for each with async enumerable, and also the equivalent for each, but for producing, so async methods with yield return in them. The for each is fairly interesting because async enumerable is not the async enumerable from system.interactive that you may have used. It's different to the existing enumerable of T. It's been redesigned particularly to avoid the overhead of creating one task per item, when often we get a bunch of stuff at a time. But fundamentally, you're likely to be able to get away with just saying, hey, there are asynchronous sequences, and I can for each over them, and I can produce them easily, and I can also dispose of things asynchronously. That may be all you need to know, and so I'm not going to give examples right now, and it's only half implemented as well. So let's go first to switch expressions, and we'll look at Fibonacci as an example. So the switch statement in previous versions of C# has been kind of ugly. It's very much based on C, and the Java design team didn't extend it much, and then the C# team didn't extend it much from that, because for all that C# was hailed as being a cross between C++ and VB, yeah, really Java had a pretty significant influence there. But the switch statements are all kind of ugly, the scoping rules are a bit weird, and it just doesn't feel quite right. Let's look at Fibonacci sequence, which hopefully you're all familiar with. So we will define fib0 equals 0, fib1 equals 1, fib n equals fib n minus 1, plus fib n minus 2 for all n greater than 1. So the sequence looks like 0, 1, 1, 2, 3, 5, 8, 13, etc. You just add the 2 to get that 13. I just added the previous 2. So we want to write a method that computes fib of n for a single value of n. And I would say that a better solution for the Fibonacci sequence is to actually model it as a sequence, so static IEnumerable of int fib, and then you can just say, well, I want the nth element of that sequence, and you can do that with yield return and all kinds of things. I'd also say we're not looking today at overflow at all, so Fibonacci grows really quickly. After about 32 cycles, this will start to overflow. I don't care for the moment. Okay, this is only focused on switch expressions. So one way of implementing Fibonacci sequence that's reasonably simple, but very imperative, is this. We have if statements, so we first check whether n is less than 0 and throw an exception, check whether it's 0, return 1, check whether it's 1, return 0 for 0, 1 for 1, otherwise return that. So it's all very much if this then that, and it's not even the answer is 0 if n is 0, 1 if n is 1. Instead it's this imperative, I will execute this block of code if n is 0, and it happens to only contain a return statement. Okay, well, we can probably spot a pattern that lets us use a switch statement reasonably easily. First do parameter validation, then switch and use a default. Okay, so far this is just C#1. Okay, we can even switch and put two things into the same place, and that's kind of ugly. But you kind of need to do that in C# early versions. We can also use pattern matching from C#7, and what we can do, you could either match against int x and then have a guard clause, or you could match against underscore, which is the discard, to say that matches anything, and I just want to express a condition in terms of n instead of doing anything else. So this is now looking quite nice. I like this as a way of saying the answer in each case is this, and I'm using patterns to describe when to do what. So this is looking good already. Let's convert that, and in fact let's fix that as well. Let's convert this switch statement into a switch expression. So the switch expressions are in C#8, and as you'd expect, it's an expression that produces a value, and every case has to either return a value or throw an exception. That's entirely valid, just like if you were calling a method. However, the syntax has changed really quite a lot. So, firstly, instead of doing switch and then putting an operand in brackets, it's value switch. So switch becomes a binary operator in this sense, and the left-hand side is the value you want to switch against. The right-hand side is a list of, well, at the moment the compiler calls them arms of the switch expression. I don't know whether it will eventually, but it's a list of things. And how do we write lists in C#? If you have a list of parameters, or a list of arguments, or a list of array elements, or a list of type parameters or type arguments, or object initializer properties, you put commas between the values. So that's what we get now. Instead of having a case that ends with, just the end of a block of code, we have a comma at the end of each arm. And that's fine syntactically because each arm consists of a condition that can use a guard. So the pattern with an optional guard clause, then a fat arrow instead of, so we don't have case, we just have the pattern, and then instead of a colon, we have a fat arrow. And then we don't have, for cases where we're returning something, we don't have a return statement because this isn't a statement. this isn't if the value is X, is 0, then execute this block of code. It's if the value is 0, evaluate this expression, and that's the result of the overall switch expression. Okay, it's a slightly different mindset between thinking imperatively, here's a set of statements, and here's an expression to evaluate. It's a rather more functional programming-oriented approach. So we just have the expression. So we haven't saved very much. These are both the same number of lines of code, and this one is a few characters shorter. So we've got rid of all the cases. Oh, and in a switch expression, you can't have default. The sort of logical equivalent of default is underscore, match anything, and discard the result. So there's no default. So we haven't saved very much yet, but the fact that this whole block, this whole section that I've highlighted here is an expression, we don't have to return it directly. We can do int result equals and then return result. Okay. But if we are just returning it directly, well, we already have something in the language to make methods that have a single statement, which is just a return statement. Excuse me. We already have syntax to make that simpler, which is to use an expression bodied member. So now we can implement the whole of Fibonacci in this single expression bodied method. And I think that's really nice. Don't go overboard with it. There will be places where doing this makes it less readable than the code you had before. But where you can, I think this has real appeal, because you can tell just from before you look at the body, it's an expression bodied member. It depends on n, because that's what we're switching on. It could also, if this, it could depend on static fields and things as well. But that the body here is only ever going to be things that map input values to output values. That's all it can do. And that's quite powerful for understanding the code at a glance. You don't need to look at the method body to know the shape of it. Whereas in this form, if you look at the signature, that just says, well, it's going to compute an int. It could do all kinds of things, but it's just going. In this case, it's just going to produce an int by evaluating expressions. Now, the expressions here can be arbitrarily complex expressions. They could call another method that does things. So I'm not going to make too strong claims about what this allows. But fundamentally, it gives a better mental model. So that's switch expressions, which we'll see now again in the enhanced property matching. So this is more case patterns that can be used with the is operator as well. So in C#7 we gained 3 patterns: type patterns, constant patterns, and the var pattern. And we had 2 places to put them. One was is expressions and one was switch statements. In C#8 we will gain another kind of pattern, which is property matching, recursive patterns, and also the ability to use patterns in switch expressions. So it's worth keeping separate in your mind. These are the kinds of patterns that exist, and these are the contexts in which I can use patterns. So the background for this example is an item class with subclasses of weapon and artwork. It's a pretty arbitrary and weird example, but we're going to create a list of items and ask for a fact about each item, and we'll have a look at what we can do. So I've got 2 methods here which are equivalent, other than one uses a switch expression and one doesn't. And this is just to show that the 2 features really are orthogonal, but I happen to prefer the switch expression version. So these look quite different to the patterns we've seen before. The weapon part looks reasonable. We could have weapon W goes to something. That's just a regular type pattern that only matches if item is a weapon and sort of extracts the value of item as a weapon reference in the pattern variable W. This part with the braces, though, this is different. So this is saying, okay, in order to match this arm of the switch expression, it has to be a weapon, and then I'm going to extract the value of its damage property and apply another pattern. So this 0 here might look like a constant, but it's actually a pattern. It's just the constant pattern. So the compiler effectively is writing code such as, I'll put it in here because I can, if item is weapon and weapon item dot damage equals 0. Okay, so this expression here is more clearly, I would say, expressed, once you're used to it, more clearly expressed as this pattern. The constant pattern is just one kind of pattern. We can extract the damage using var or int or any other pattern is fine. And so here we've got a new pattern variable called D. We've also got a pattern variable called W. We're using D so that we can check in a guard clause what the damage is, and then we're using W so that we can say that it's, give it to string representation. We don't have to extract that W. You can just extract the damage. You can also, as a new type of pattern, do deconstruction. So, in fact, I'd need to check whether this is actually a new kind of pattern or just more recursive patterns. But this is using the creation date property and saying I will deconstruct that. So that is a date time. And I've got an extension method called deconstruct that takes a date time and has out parameters of out year month day. So this was a C#7 feature that you could do deconstruction like this. However, it's not been available with pattern matching before. Now you can deconstruct to, this is a new pattern variable called year. So any artwork, because this will match any date time, any artwork, we're just going to print the year property, the year part of the creation date property. Okay, that was quite a lot to take in, but this is just new patterns. These are somewhat extreme examples, and the examples that are given in the build demo are also pretty extreme. But things like doing it at this point or that point are not so bad. You can do it against multiple things. You could do when d greater than 100 and desc.length greater than 10, for example, or we can use desc here. So you can match against multiple properties and extract their values and things. It's pretty flexible. And as you can see here, we're matching we're not just using a simple match, we're using deconstruction as well. And you can nest things and go to your heart's desire, but keep it readable. Okay, so that's switch expressions and additional patterns. They sort of come together and work very well together. So I'll stop briefly to see if there are any questions about that before showing you indexes and range.
Any questions? Yes, go ahead. With the result expressions, can they be put into curly braces with a return, or is it just a one statement and that's it?
It's got to be not even a single statement. It has to be an expression. So it's kind of the same rules. Well, it has to be an expression that produces a value that's that works with the overall type of the switch expression. I don't believe you'll be able to do a switch expression which, so let's put it up here first. Whereas you can write, let me take a step back, you can write void methods, print foo, and still use that. Still use an expression body member. And that's using a statement expression. I don't believe you'll be able to do item switch and then do, well, let's just do null goes to console.writeLine null, and anything goes to stuff. Sorry, console.writeLine stuff. Nope, that doesn't compile. And I think if I did var result, then yeah, we can't assign void to an implicitly typed variable. If I make it non-implicitly typed, no, you just can't do statements that don't produce values. I should say the compiler attempts to check whether you're exhaustive. So suppose we don't have that final arm. Then what do we expect to happen? If we call getFact with something that isn't a weapon and isn't an artwork, then the compiler warns us that the switch expression does not handle all possible inputs. It is not exhaustive. More interestingly, when we try to compile, we actually get a compile time error, but not one that's reported nicely, because eventually the compiler fails to emit valid IL. So yeah, failed to emit module demos. So I think the compiler tries to, it effectively tries to emit a method that doesn't always return something, and that's just not valid IL. So that will be fixed, that little bug will be fixed, I'm sure. It's possible that the team is discussing whether non-exhaustive switches should just throw an invalid operation exception, for example. But at the moment, it just breaks. So to go back to the actual question, no, you can't write a set of statements in braces. What you can do, if you really, really want to do that, and I'm absolutely not suggesting that you should, you could return you could create a func that does console.writeLine, I'm in a switch. In fact, let's put this on its own line. So that's now a delegate that returns a string. We've cast it to func of string, and we can now invoke that. So that works. That is an expression of type string, I think, at some point. My brackets not quite match up. There we go. Yeah, so that compiles. Don't do that. It's horrible. If you want to use multiple statements, then write a switch statement. Or write a method that... So if you put all of this into a string get harmless, and then had all of this, that's entirely reasonable when it's static. And it's entirely reasonable that a lot of your switch arms, your switch expression arms, will want to call methods and things. So it's not necessarily just evaluating just operators or anything like that. But you can't have multiple statements directly in the switch expression without the horribleness of that I just showed you. Cool. Any other questions? Nope. Okay. Sorry, was there one about to happen?
No.
No. I think it's when I start speaking, I get a little bit of echo back before Skype realizes and squashes the echo, and I think it's someone starting to ask a question, but no, it's just me. Right. So, on a really, really different matter, there are two new types that will be part of the framework, and there'll be NuGet packages, I'm sure, that allow this if you're not using modern frameworks. There'll be index and range. An index consists of two parts, two aspects. One is its sort of distance, its value, and I think it's called value, index dot value, there we go. And the other is whether it's from the end or not. So index dot from end. And it's whether it's from the start or the end. So this version will have a value of 1 and a from end of false, because it's from the start instead of from the end. There is a conversion from int to index. There's also a new operator, the hat operator, which creates an index from the end. This is all stored in a single int, and it can only do that because an index can never be negative. So if I do that, it will either not compile. No, it compiles okay, but that would throw an exception, as would hat -2. I should point out that indexes, we can use indexes with indexers. This is not magic. This is a new string indexer. In fact, it's an extension indexer. That is kind of magic. We can see it in here. So one of these is the right thing. Right. So get indexer extension. I don't know whether this is what extension indexers will look like, but this is an indexer for string that takes an index. Don't worry about the definition and the fact that it's in my code at the moment, but let's look at what it returns. It's the equivalent of the regular indexer with an int, except it handles being able to go from the end instead of the start. So, as you might expect, if we do text with index 0 from the start, that returns C. Text with index 1 returns O. Text with index 2 returns N. What you might not expect is what happens if we do text with an index of 0 from the end. That would throw an exception. This is 1 from the end. This is 2 from the end. This is 3 from the end. Now, that may look really odd to start with. There are there's a good way of thinking about it, and there's a really good reason why it is that way. The good way of thinking about it is that an index here isn't the character, it's a flashing cursor, and this flashing cursor is 0 from the start, and you always select the character that starts at your cursor. So you select that, and that's 0. My cursor is now 0 from the end. It's at the end. And if I try to select the character after it, bang, there isn't one. Now my cursor is 1 from the end, and I can select it. Okay. They could have decided to do things a different way, but it really becomes important when we have ranges. So an index is just a single index. A range is a pair of indexes, a start and an end. We have, you can create them explicitly. Range, range constructor equals new range, range dot create. There we go. And that will take 2 indexes. So we can take 1 and hat 2. So these are equivalent with this new dot dot operator. And indexes don't have to be provided. So as in, you can have a range that's everything up to hat 2. Up to hat 2. Naming fail. So that's only got one side. We could do from 2. That's fine. We can even do, and this will be rarely useful, but we can ask for everything. All good so far. So a range is a start and an end, and this is equivalent to 0 to hat 0. Okay? What do we use these ranges for? We use them to create slices of things. So we can slice into a string, and this will currently create a new string because of the way that string works. And that's slightly unfortunate, but hey, it's okay. We could take the string and treat it as a read-only span of char. And at that point, when we slice the span, which we should be able to do with a range thing, but there's a few issues on this preview. We get another read-only span, and the difference between doing this and doing this is that this span slice does not need to copy any data. So suppose we had a string that was 1 million characters long. This operation is expensive. This operation is dirt cheap. It just has something in memory saying, well, I go from there to there. I've shown everything with strings, but also shown that it works on spans and will work on spans. There will be extra methods and indexes available. It will also work on arrays that I think will return a span when you slice into them. And this is very good because it provides one uniform way of referring to a range within something. Aside from anything else, it's nice to be able to say, suppose I had string quoted equals hello to Adelaide, and I wanted to get the unquoted value. Currently, that would be really ugly. Quoted.substring 1 quoted.length -2. Okay, we can't use the substring takes the length that we want, not the final offset, and we've got to find the length of quoted anyway. I want to be able to just do quoted.substring, and you can, there'll be an overload for substring itself, but 1 ... hat1 is great, or just take the indexer. That's so much briefer and says, I want everything from 1 up to but not including, and this is the other point where the meaning of hat is important, the final character. So the fact that this is exclusive is important. So if we have the total range, then that returns everything. 1, that returns all the way up to the end, which means that hat0 has to mean all the way to the end, which makes more sense with the indexing. So this is, as I say, this is entirely different from all the other features. It's kind of an interesting little feature in terms of being fairly isolated from other things. It will maybe depend on extension indexes and things. It's not clear to me yet how we get away with, well, string will have an indexer in maybe .NET Core 3.1 that accepts an index and a range, but what happens if you're using .NET Standard? There needs to be one package that contains index and range, and also the extra extension indexes and things like that. But I'm sure they will work their way around it. But I think you'll agree that it's different in flavour to either nullable reference types, which are really very different to everything else, and switch expressions and patterns that are sort of more of the same. Here we've got 2 new operators. We've got the range operator and this unary hat operator that doesn't exist at the moment. Those are all the features I was planning on talking about today. Not all the features may make it. It's entirely possible that indexes and ranges will go. We don't even have a beta yet. I would expect by the time we get to a beta of Visual Studio 2019 that the feature set will be reasonably stable. I strongly expect that nullable reference types will be in. I expect that everything that's already been implemented and is in a preview probably will get in there. I expect that async extra language features will get in there, even though that's not entirely implemented yet. There are a bunch of other things. So record types probably won't make it. Default interface implementation may or may not make it. And there are a bunch of other features that have been discussed and designed to some extent, but haven't been committed to for C#8. So I've only given you a look at a few features today: nullable reference types, switch expressions, additional patterns, indexes and ranges. I've very briefly described async. I fully expect there will be more, and I would I encourage you, if you have a machine where you can easily install betas, then at least when the beta comes out, try to get ready for C# 8. It's going to be quite a big release. With that, thank you very much. I'm open for questions.
Any questions?
Yeah, are we expecting to see these same sort of features across the .NET languages, or is this a C# only sort of thing?
Right, so the question is, in fact, I don't need to explain this time. I'm used to having to repeat questions for other people that couldn't hear, but if I can hear, you probably can. Do we expect this feature in other .NET languages? I wouldn't be surprised if some bits made it to VB. So indexes and ranges, I think it may well be entirely reasonable. Admittedly, you don't need, given that you can create an index without the operators, and you can create a range without the operators, VB developers will be able to use index and range even if the language doesn't move forward. But it feels like the kind of thing where they might move forward. I don't expect them to get nullable reference types. I don't know how much has happened with pattern matching in VB. If they haven't got pattern matching yet, then I really wouldn't expect either switch expressions or more patterns. I suspect that they will get at least some of the some of the async language features, because there will be new interfaces that are relatively hard to consume directly, and it would really leave the VB developers behind if people were producing class libraries that use these interfaces and they're hard to consume from VB. So, without having spoken to the team about this at all, that's kind of where I expect the lay of the land to be. A long time ago now, sort of back in C# 5 timeframe, there was a push for C# and VB to have feature parity. My understanding is that push for parity has entirely gone away. There is no expectation that VB will stay a vibrant language at the same cutting edge as C#. I'm just going to stop sharing my screen because I realise I'm gesticulating and you can't see anything. So yeah, I don't expect VB to move in the same way. F# already has its own entirely different and disparate feature set. It would be interesting to know whether F# will use the same annotations, same attributes that C# uses for nullability, so whether it can consume them, whether it automatically puts them on, that sort of thing, but I don't have any information on that.
Can we say these features are more optimized in terms of the CPU and memory utilization?
So I wouldn't expect a switch expression to be any faster than a switch statement. As I've mentioned, unless they do implement the bang at the end of a parameter feature, then the IL generated for nullable reference types won't be any different to non-nullable to previous versions of C#. The indexes and range stuff, I expect the framework to make sure that will be efficient, at least on modern frameworks. But I don't think any of the language features themselves, unless we get a new CLR, then we can't use any new IL features, and I don't think any of the language features themselves particularly lend themselves to using a different form of IL. Using the async sequences, the new interface will be more efficient than the existing system.interactive iasync enumerable, because it avoids having a task for every item returned. But that's more of a framework thing that the language makes easy than here's a language feature that we can implement in an optimized way. Yeah, at the front.
Hi, I was about to buy your C# in Depth fourth edition from Manning's.
Right.
Should I hold off?
Please don't hold off. So that's currently in early access, and it's getting really close now. It covers C# 7 7.0, 7.1, 7.2, 7.3, and it has one chapter at the end which describes all of this in a bit more detail. But it's still, I'm telling you today my best guesswork, and I wrote the chapter on C# 8 a few months ago. Not a lot has changed, so I won't be updating that. But I'm not going to wait for C# 8 because that would take forever. There might be a 5th edition at some point, although I'd quite like a break from writing at some point as well. Yep.
Hi. I just wanted to know what your thoughts were on the interfaces with default implementations and just what ramifications that might have for things like IOC containers and those sorts of things.
Right, so the feature that's been asked about is default interface implementations, where when you declare an interface, you can put methods with implementations in, and then those implementations can be overridden by implementations of the interface. So a good example would be IEnumerable could have a count method where the default implementation iterates over it and returns the number at the very end, and then list could override that method and return a more optimal version. And this would be nice in terms of if you think about what linked to objects does, it knows about a few interfaces. So its count method says, well, if you implement iRead-only list or iList or iCollection of T, etc., then we'll use the count property declared there. But if I want to create something which I happen to know the count, but I don't want to provide, I don't want to implement one of those interfaces, there's no way that I can get an optimized implementation out of linked to objects. Whereas if we had default interface implementations and they were used in that particular way, I could just override it. So that's very nice. To be honest, probably the biggest reason why this is being considered is for Xamarin Support. Microsoft now owns Xamarin, so they have a bit more reason to support things that Xamarin needs. And Java these days has default interface implementations. And so if you want to interoperate with Java, which Xamarin does a lot for Android, you kind of need something like this. The downside is that it requires, well, there are a couple of downsides. One is it can be a bit confusing until we all get used to all the ramifications and versioning issues and things. It will be a little bit confusing. But also it needs CLR support. So unless they're going to do CLR work and do a big bang release at the same time, I expect that it won't be present in C# 8. Now, the question mentioned IOC containers. The question suggests that you've thought about this more than I have, in that I can't immediately think of any relationship between IOC containers and default interface implementations. Now, you're welcome to clarify the question, but it probably means I won't have a good answer.
Yeah, that's fine. I'll do some more research.
Right. Okay. Cool. Feel free to email me with or ask a Stack Overflow question saying, this is what I think the ramifications will be. Are there other ways, or whatever it is? Cool. Any other questions? I think pizza's about to arrive, isn't it? So I can almost hear the rumbling stomachs.
All right. Well, would you thank Jon for speaking here?
Thank you very much. My pleasure. Oh, and the awful thing is, I'm sleepy now. You'll be able to go to bed in a little while. I've got the rest of the day to work through first. But anyway, good evening and enjoy your pizzas.
Cheers.
Bye. Thank you.